So these are the 10 problems need to know. So this is the set 1. So we can have 3 sets. So let's look at the first problem. So the first one is e to the negative 2t dt, and we know that there's a shortcut. When we have a constant, the solution is going to be you divide by the constant, so that means this is simply e to the negative 2t negative 2 plus c. So this is negative 1/2 e to the negative 2t plus c. So let's go to the question number 2. Question number 2 is about like 4 divided by 3x plus 5 dx, and you can see that this is a natural log problem. So what we can do, we can look at the derivative of the bottom function, which is 3. So what we try to do, we try to get the 3 in the numerator. So what we do, we get pull 4 and then we put 3, we divide and multiply by 3, so we can write it like that. So we kind of rearrange the terms, and then what we can do, so we can write this one as 3x plus 5 dx. Now you can see this is the natural log, so it is 4/3 natural log. We need the absolute value because we don't know whether this is positive or negative, so we put the absolute plus c. So that's the answer for that question. And then number 3, so let's look at this one. So it is 3x plus 5 divided by x squared plus 7 dx. And you can see that if you look at this problem, the top is not the derivative of the bottom function, so the trick would be to split this. So we're going to split this into 2 fractions first. So we're going to have 3x over x squared plus 7 dx. That's the first one. And the second one is 5 divided by x squared plus 7 dx. And you can see that we can do these two separately. So as we did before, we're going to take 3 out, and the derivative of the bottom function is 2x. So but we have 3, so we can divide by 2 and multiply by 2, and we write this one as x squared plus 7 dx. And in the other one we can pull 5 out, so this is going to be a tan inverse problem. So so that means your answer is simply 3/2 natural log. This is always positive, so we don't need the parenthesis here, absolute here, sign here. And then here you can see that this is tan inverse. A is square root 7, so we're going to divide by square root 7, and this is going to be tan inverse x over square root 7 plus c. Okay, so number 4. So let's do number 4. And one of the thing that we know about integral calculus is there is no product rule. So that means if you want to integrate this product, so let's say 2x minus 1 times x plus 3. Unfortunately, there is no product rule. So what we can do, we can split. So if you split, you're going to get 2x squared plus 5x minus 3 dx. Now what we can do, a term by term integration. So you're going to get 2/3 x cubed plus 5/2 x squared minus 3x plus c. Very easy. And similarly, there is no quotient rule as well. So that means if you want to do this problem, so there is no quotient rule with integral calculus. So how about this problem then? So let's do this one. So it is x squared plus square root x plus 3 divided by, let's say, x, something like that. So this is a quotient, so there's no quotient rule. So as we did before, what we're gonna do, we're gonna split, we're gonna divide by x all three terms. So that means if you do that, you're gonna get x when you divide the first term. A second term, you're gonna get 1 over square root x. From the third term, you're gonna get 3 over x. So that's what happened when you divide term by term. Now it's very easy. We can integrate them just using the power rule. And then, so what's going to happen, actually what we can do, we can slightly arrange this one. So this x, that's okay. This one is x to the negative 1/2. This one is the log form, so we leave the x there. That's a special situation. Now we can see that we can integrate them term by term. So the first one is going to give you x squared over 2. The second one is you want to add 1, so it's become 1/2. So divide by 1/2 means multiply by 2, so it's a 2 square root x. And this one is log, so it's x. We don't know whether x is positive or negative, so we put the absolute sign there, plus c. And let's do number 5. So number 5 is how about this problem? So it is t squared minus 1 dt, and then you can see that this is a very simple problem. So the reason is, you can see t is the derivative of t squared minus 1 without the constant. So constant you can always manipulate. So what we're gonna do, we're gonna try to create the derivative in front. So that means we're gonna divide and multiply by 2. So it is 2t e to the t squared minus 1. Now you can see that 2t is the derivative of t squared minus 1, so we can just use the formula, or the this is one of the 4 formula situations. So 1/2 e to the t squared minus 1 plus c. So you don't need the substitution method for these kind of situations. When you see the derivative, you can just write it like that. So this is simply coming from what we normally call the 4 formulas. So F4 formula. So you can look at, there's a video for that, so you can learn that method from that. Okay, so let's move on to another important technique that we call the partial fraction method. So let's do a problem from partial fraction. So number 6 is a partial fraction problem. So x plus, so we can do x plus 3 divided by, let's say, x minus 1 and x plus 2, a problem like that. So if it is not factored already, what you want to do is you need to factor the bottom first. We don't want to factor the top, but we need to factor the bottom. So that's one of the requirements. So but since already factored, we don't want to do that step, so it's one step closer. So let's write the form. So it's x plus 3 divided by x minus 1, x plus 2. This is identical. Some people put equal sign, that's actually wrong, because we need an identity property here. So it should be identity. X minus 1 plus b over x plus 2. So now what we can do, what we normally do is we're going to multiply by the denominator from the left side. So when you multiply by the denominator, you're going to get x plus 3 identical to when you multiply by that, you get the other term. So that means x plus 2 here plus b x minus, that's the other term. That's what you always get. Now what we can do, we can use the substitution technique, that's much faster. So we're going to substitute x, so we're going to say subs x equal 1. If you plug in x equal 1, you're going to get 4 equal 8 times 3 plus 0. So that's going to give you a, so a equal 4/3 in this case. And then we're going to substitute x equal negative 2 to cancel the other term. So if you plug in negative 2, you're going to get 1 equal 0 plus b negative 3. So this is going to give you b equal negative 1/3. So we're going to get the two terms now. So now what we're going to do, the simple trick, we're going to integrate term by term. So now what's going to happen is your integral x plus 3 over x minus 1 x plus 2 dx is simply equals to 4/3 1 over x minus 1 dx minus the 1/3, that's the constant, we write it outside, over x plus 2. Now you can see that these are very simple log functions. So it is 4/3 natural log x minus 1 minus 1/3 natural log x plus 2. We need the absolute sign because we don't know whether they are positive, so we write it like that. So that's the problem. It's very simple. And then so we can try a simple like a integration by parts problem. How about that? So let's do number 7. How about this problem? T e to the negative 2t dt. So so you can see that so this is not substitution. Why this is not substitution? The t is not the derivative, so you have to use the integration by parts for this kind of problems. So we're gonna use the trick. We know that in integration by parts there are 3 types. This is the first type. So when you have a exponential function, we're gonna pick the other function as t as u, so that means u equal t in this case, and then du equal e to the negative 2t dt. Take the derivative, so du equal dt, and take the integral. So this is negative 1/2 e to the negative 2t according to the formula. So now we can finish the rest of the integral. So you can see this is uv minus v du integral. So that means uv. So that means the product of the two, that means negative 1/2 t e to the negative 2t minus v du, that means negative 1/2 e to the negative 2t dt. So you can see the second integral is very easy to integrate right now. So it is negative 1/2 e to the negative 2t negative positive 1/2. You again get negative 1/2 e to the negative 2t plus c. So that means if you simplify, it's negative 1/2 e to the negative 2t, and then actually this is going to be negative again. So it's going to be negative 1/4 e to the negative 2t plus c. So you can see it's very simple. It doesn't take too much time, but that's the problem. So number 7. So let's do number 8. So as the number 8, I'm gonna do this problem. So this is a problem that you need a trig sub. So it is 1 over x squared plus 4 square root dx. So this is a trig sub problem. So you want to figure out, we know that there are 3 common trig subs, but you know that for this kind of problem, when you have x squared plus 4, you're going to go a tan theta, a equal 2. So that means x equal a tan theta. Take the derivative, so dx equal here a equal 2, so it's a 2 tan theta. So it is 2 secant squared theta d theta. So that's what happened. Now what we're going to plug in them. So let's plug in them. We're going to substitute for x and dx both. So it's going to be 1 over. So if you substitute for x equal 2 tan theta, so what's going to happen? Actually, we can put 2 there. So so this is 2. So we're going to have, so what we're going to get? We're going to get 2. So that means you're going to get 4 tan squared theta plus 4 square root dx equals to 2 secant squared theta d theta. So let's simplify. So what's going to happen? You can pull 4 out. Under square it's going to be 2. So you're going to get tan squared theta plus 1 square root, and then 2 secant squared theta d theta. Now we know that 1 tan squared plus 1 means secant squared, so we know that identity. So we know that 1 plus tan squared theta is secant squared theta. For if we use that, what's gonna happen, actually 2 get cancelled, so what's gonna happen is the bottom becomes secant squared, but under square root simply becomes secant theta, because under the range, so the range is from negative pi by 2 to positive pi by 2, so under that is positive. So so you're gonna get secant squared theta d theta. Now you can see that one secant get cancelled, so you're gonna get secant theta d theta. And then this is one of the common integral, so secant is simply natural log secant theta plus tan theta plus c. Now what we can do, you cannot leave your answer using theta, so what we can do, we can draw the corresponding triangle. So if you look at the identity, it says that tan theta is equals to x over 2. That means we can draw the triangle. So if you draw the triangle, so this is theta, so you're gonna get x over 2, so that means this is gonna be x squared plus 4 square root by the Pythagorean identity. So we can find all the ratio we need now. So so that means it's ln. So according to this one, the secant gonna be hypotenuse over adjacent, and then plus tan gonna be x over 2. So what you can do is you can leave it like that, that's okay, but that's not the best answer. What we can do, we're gonna pull the constant out. So if you pull the constant out, you're gonna get x squared plus 4 plus x, and then you're gonna get c minus ln half, but this whole thing I'm just call c because it's just a constant. So so that's the whole problem. So and then let's do number 9. So number 9, we're gonna do a problem from maybe a trigonometric substitution. So let's do one from trigonometric substitution. So number 9. So this is a trigonometric substitution problem. So it is sin 5x cosine 4x dx. So this is a trigonometric substitution problem, and you know that by the theory, when you see a odd power, sine has odd power, we use the other one. So we use the other one means cosine. So that's it. And then du equal, so it's a negative sine x dx. So that means you need a negative sign. So what we can do, we can put the negative sign here, and also we need to isolate one sine term. So we can write this one as sine 4x, and then we can have cosine 4x, and then negative sine x dx. We write it like that. Now we can substitute for this. So this simply becomes negative. Sine 4 we can write as sine squared, and this is cosine 4x minus sine x dx. So let's substitute now. So it's a negative, but this one is actually 1 minus cosine squared x from the Pythagorean identity, and then you can square that, and then you have cosine 4x minus sine x dx. Actually I write a lot of steps, but some of the steps are not necessary. So then we can substitute. It's a 1 minus u squared is a u to the 4th, and then you can see that the whole term simply become du, the last term. So now we're gonna expand this. So if we expand this, this is gonna be 1 minus 2u squared plus u to the 4th du, and then you can see that you can bring the negative sign inside and multiply by u to the 4th. So you're gonna get you can leave the negative sign outside just for the moment. So u to the 4th minus 2u to the 6th plus u to the 8th, now we can integrate by u. So if you integrate by u, this simply becomes u to the 5th over 5th minus 6th u to the 7th, actually u to the 7th, not 6th, so it's going to be 7, and then plus 9 u to the 9 plus c. Then you can multiply by the negative sign and substitute for cosine, so then you will get negative cosine 5x over 5, and then minus plus, so it's a 2 to the 7 cosine 7x, and then minus 1 over 9 cosine 9x plus c.